right, so here's the next topic we're going to start on. This is called oxidation numbers. Okay, Maya, would you do me a huge favor? And again, you have that sheet if you can't read it up here. Will you please read letter A, the first dark bullet, and the first sub-bullet? Pause right there. Electron distribution. What does that mean? Like, can someone explain that to me? What is that? What is distribution? To move around and change, right? UPS, FedEx, those are distribution companies. So this is the important part. Go ahead. All right. The key word there, and I want you to underline this if you have your pencil, please. The key word there is specifically. So whenever we talk about a compound, let me give you a hypothetical compound. So this is number 1 on your paper. Do me a favor. We're going to need some spacing here. So kind of maybe start on the second or third line down and space it out just a little bit. I mean, don't make it all the way across the page, but we are going to need just a little bit of space. SO4. So my question to you is this a compound? Yes. Mini quiz. Name it. Sodium sulfate. Better know your polyatomics. Okay, so this is a compound. Let me ask you something. Are a bunch of atoms sticking together to make this thing? Yes. What specific part of the atom allows it to stick together? What specific part of the atom? What's those things moving around? Electrons. So here's what oxidation numbers are. Oxidation numbers are, again, reading this last bullet, which means how many electrons is each atom sharing specifically. So my question to you now returns is, how many atoms are present? Not total atoms, excuse me. How many elements are present? 3 elements. Who are they? Sodium, sulfur, and oxygen. Now here's the next question. How many total atoms are present in this thing? 6. 1 sodium, 1 sulfur, 4 oxygens. 6. So we've got 6 atoms that are stuck together in this funky looking thing, and we've got all these electrons that are running around. So here's the next most important part, is we've got to figure out how the electrons are going to be moving. Do you agree that some atoms take electrons? Do you agree that some atoms give electrons? Well, our goal is to figure out who's taking and who's giving, and not only who's taking and who's giving, but also how many each are taking and each are giving. So let's read the next one. Jalen, will you please read me B, just the first bullet? All right, here's what I want you to underline here. They are assumed to belong to the more electronegative atom. And then circle the word more. Circle the word more. And I'm going to go back to that first, I'm going to go back to the example we were looking at. In this special compound, you should already know this, who is the most electronegative in this thing? Oxygen. How do you know that? Perfect. It's closest to fluorine. Now, my next question is, how many oxygens are in this thing? There are 4 of them. So you've got 4 really big bullies that are out to get some electrons. Do you agree with that? Well, here's the deal. What do we know about sodium and its 1 valence electron? What is it trying to do to it? It's trying to get rid of it. Well, we know sodium is going to be the easy guy. But then when we look at sulfur, in comparison, do you agree that sulfur is still kind of close to fluorine? So it's still going to try to get some. But guess what those 4 big bad oxygens are going to do to sulfur? It's going to beat him up and take it. He has no choice. So that's what we've got to determine, is how many electrons that sulfur is going to have taken from it. Okay? That's the whole goal of this thing, is figuring out how we can satisfy the needs of those 4 oxygens. So here's the rules. Here's what we're going to do, and we're going to be able to solve for all this stuff. And like I said, if you can do basic math, all of this stuff is going to be easy. Now, I kind of want to explain the thing that's in this box. Every year, the number 1 most missed part of this particular section is people give me the wrong number for the answer, even though their work is correct. The first thing I want you to find on there is, whenever we start doing these numbers, where will the answers come from? Where is that? On top. Again, this whole topic is on what? Oxidation numbers. Well, where are our oxidation numbers? They're on the top. And so when we start working with this, you'll understand what I mean by where are my answers. All right, so let's go back and look at this. So let's follow along in the rules. So rule number 1. Lily, will you please read me rule number 1? All right, pause right there. And this is my mistake. I should have already done this, but I want you to write this in for me if you guys do not mind. Look for, and what is that funky looking thing at the end? Positive or negative. Now, if you see one with your eyeballs, if you see one of those two things, what is the answer to that question? Would it be neutral or would it be charged? It would be charged. So if you see these things, that's what those are referring to. So let's go back to the example problem. With your eyeballs, do you see a positive or a negative? No, you do not. So, Lily, read me that first sub-bullet. What does it say? Or first of all, let's answer the question. So is this thing neutral or is it charged? It's neutral. So, Lily, read me the first bullet. All right, so here's what I want you to do. Set this whole thing, and this is where you have to set it equal. Put the number right there and set it equal to 0. And again, I got the question earlier. Why do you put a slash through your zeros? Because we use so many oxygens. I don't want you to think that they're oxygens. I want you to make sure that you know they're zeros. That's rule number 1. Okay? All right, let's read rule number 2. Blaze, will you please read me rule number 2? Loud so everyone can hear. All right, so let's pause right there. So what he just said is that they're by themselves and there's nothing else attached. Are any of these things by themselves? Is there more than one thing present? Yes. So is this thing by itself? No. So does this rule apply to this example? Skip it. So let's go to the next one. All right, Miss Anijah, will you please read me rule number 3? Oh, hold on. Something's not right here. This is wrong, isn't it? This is a different sheet. Well, that's weird. All right, this sheet is out of order. What you have is right. The one that's up here on this board is wrong. So I'm going to have to bounce it back and forth. So this should be the next one, correct? Yes, that should be rule number 3. All right, so now, so please read this one. No, y'all should have. No. This should be rule. Oh, poop. All right, so I'm going to completely stop looking at that, and I'm going to let you read. What is rule number 3? Really? That should be her 4. Bring it to me. Bring it to me. Bring it to me. Then we need to swap then. All right, hold on. All right, Anijah, my apologies. Let's try this one more time. So will you please read step number 3? Pause right there. Yes or no, ionic. How do you know? It's a metal and a polyatomic ion. This is ionic. Okay, keep going. Pause right there. So my first question to you is the first element in this compound a metal. How do you know? It's in group 1. So then keep reading. It says group 1s are always what? 1 plus. So here's what I want you to do. Remember, oxidation numbers, the answers are written where? On top or on bottom? On top. So right here. So we're going to talk about +1. So we know that sodium is +1. Hold that thought. We'll get there. Hold that thought. Okay? All right. So we know this one. Tristan, read me the first 2 words of the number 4. Fluorine always. So let me ask you something. Is fluorine anywhere in this? So do I even need that rule? No, but I do want to address it at this time. The second word is always. What does always mean? Always, right? That's a dumb question. So will it ever be anything different than? No, let me ask you this. So keep reading. Fluorine always has an oxidation number of -1, and here's why. In all of its compounds, because it is the most electronegative element. The very top, a minute ago, you underlined it. It said that electrons are assumed to belong to the more electronegative element in each bond. Well, you've already told me in this bond who is the most electronegative. Oxygen. So is oxygen going to be taking the electrons or giving them? Taking. So keep that in mind. All right. Marquise, will you please read me the first two words of number 5? Oxygen. Now, is oxygen in this? So we're going to have to worry about this rule. Now, what does it mean by usually? Most of the time. So can it potentially change? All right, keep reading, Marquise. Now, here are your two exceptions. I'm going to be honest with you. These are very rare. Remember how I told you I hate compounds with peroxides and mercury? You may or may not remember that. One of the examples is when peroxides, oxygen has an oxidation number of -1, which I will probably honestly never give you on purpose. And the second one is when compounds with fluorine. And we just read fluorine what? Always has a specific number. Well, when oxygen's with it, that's why it's going to have to change. So do me a favor. Remember, oxidation numbers go top or bottom? Top. So oxygen is going to be -2. Does that look familiar to you? It should. Okay. Well, here's the deal. Let's keep reading. Terrell, read me number 6, please. Pause right there for me. Hydrogen. Do I even need it here? No, but let's just discuss it because it's the first time you've seen it. So keep reading. All right, read the exception for me. Let me ask you this. When it's negative, what does that mean? Is it gaining or losing electrons? Gaining. And it says when it's with a metal, it's -1. What do we know about all metals and their electrons? They're trying to get rid of them, right? They're positive. So that's why hydrogen flips to negative. But we don't even need that rule, so we're going to keep going. So here's the deal. We've got sodium. We've got sulfur. We've got oxygen. So I need to find that number. And there's only... Go ahead. No. And here's why. That's why this is a little different from group numbers, because since there's multiple atoms going on, that one sulfur is not the most electronegative, so it can't take its group number. So because if you put in -2 right here, that's impossible because there's so many electrons that are moving back and forth. Because think about it. You're telling me that one sodium atom is going to give away 1 electron, and then this sulfur is going to gain 2 of them, and this oxygen is going to gain 2. Well, we only gave away 1. Do you see what I mean by that? Okay. All right, so here's what we got to do. Go ahead. You don't get it? All right, so do you agree that when it's negative, that means it's gaining electrons? You with me on that? So this oxygen is gaining 2. So far, how many have only been given away? 1. Well, there's no way that you can gain 2 and only 1 be given away. I'm going to fix all that. What Massimo said is, don't you just look at the group and that's -2? Well, if we filled that number in, would you agree that we would be done? We wouldn't need to do anything else. But if that's the case, sulfur gained 2, oxygen gained 2, but how many was only given away? That's impossible. That can't happen. That's what we're fixing to solve for. We're fixing to figure out what that number is. Okay? So, this is the part where we actually can go back to this because this is correct. So, it gives you explicit instructions. When you go down, what do you do with your numbers? Multiply. So, here's what we're going to do. We're going to start with oxygen because it's the easiest. What is -2 times 4? -8. Now, the only other number we have is sodium. And what is understood to be sitting right there? A 1. Well, what is +1 times 1? +1. Well, what I'm going to do is I'm going to fill this, I'm going to put a blank right there. Do you agree that sulfur has to have a number? In the very beginning, you told me that this whole entire compound was equal to what? 0. Now, there's 2 ways to do this. You can do common sense logic, or you can actually turn it into a math problem. Some of you are like, I don't want to do math. Let me just do common sense. But let me show you the algebraic logic, or the algebra part of it. So it would be positive 1 plus x minus 8 equals 0. If you were in 7th grade, you could have solved that. How much you'd rather have that on your test than what you're doing now? So you can still do this. It's not hard, but I just look at it and say, I need it to equal what? I've got 1 positive, I've got 8 negatives. What has to go in that blank? Try that again. A positive 7. A positive 7. Now, again, I said this in the very beginning. Where do your answers come from? The top. And do I have a number up top yet? No, let me go back one more time to this other sheet. When we go up, what do? Divide. But very simple. Hang on one second. What's sitting right there? A 1. Well, what is 7 divided by 1? 7. Go ahead, Anaja. No? Yes? Yeah, so 7 divided by 1 is 7. You come down on multiply, going up on divide. It's really simple, guys. Don't overcomplicate this. Don't overcomplicate it. Yes, sir. That's negative 8. Would you agree? All right. Positive 1 coming down times 1 is positive 1. Okay. Where did this positive 7 come from? From this thing needing to equal what? 0. But remember, my answer has to come from up here. Very good. Yes. Does that make sense now? Go ahead, Gage. All right, that's a good question. If you follow the rules, the first rule we came to was if it's a metal, it's its charge. That gave us positive 1 for sodium, correct? The next rule we came to that applied here was oxygen. It's negative 2. We did not have a rule for sulfur, so we've got to solve for it. You with me? Let's look at another one. Okay, let's just follow the rules. Rule number 1, determine if the compound is neutral or charged. Do you see a positive or negative with your eyeballs? No. So this is what? Neutral. What do you set it equal to? 0. Very good. So we're going to set it equal to 0. Do you see a positive or negative anywhere in it? Does that answer your question? Okay. Step 2. Atoms by themselves are 0. Is there an atom by itself? Nope. Keep on moving. Number 3. If it's a metal, well, I'm going to stop right there. Does anyone see a metal anywhere in this? I don't need that rule, so I'm going to move on. Step number 4. Fluorine always. Do I need that one? Keep on moving. Number 5. Oxygen usually. Do I need that one? Yes. Okay. It's not one of our exceptions. It's not peroxide, and it's not with fluorine. So oxygen's oxidation number in this case is what? Negative 2. And then the last rule is hydrogen. Well, what's the problem? Nitrogen doesn't have one. I've got to figure out what nitrogen's number is. Well, let's just start our math. You got it? All right. So as I go down, what do? Multiply. Negative 2 times 4 is negative 8. Now this time, this is even easier. If you want to do the algebra, x minus 8 equals 0. How many of you would love to have that on a test from Ms. Jane Folds? We all would, right? You would pray for that. So don't give me trouble when I ask you to do basic algebra when you would beg for this in a math class. This is super simple. Don't mess this up. It's too easy to mess it up. But again, I like just basic common sense number approach. If I've got to have it equal to 0, I've got 8 negatives, what do I have to have? I'm staying here. Don't get ahead of me. I've got to have 8 positives. Don't get ahead of me. All right. So now, this is the part where I asked you a minute ago. When you go up, what do you have to do to these numbers? Now you've got something to divide by. So 8 divided by 2 is, that's your final answer. Now you start to see why I mean divide. Because here's the deal. In this compound, how many nitrogens are there? 2. Each nitrogen, first question, give or take? How do you know it's giving? It's happy, it's positive, right? It's a good thing. So each nitrogen is giving 4 electrons. Each oxygen is gaining or is giving or taking? Taking 2 each. Well, if you've got each nitrogen giving 4 and you've got 2 nitrogens, how many total would that be? That'd be 8 electrons moving. Each oxygen is taking 2, and there are 4 oxygens, so how many total would it be? 8. Well, you've got 8 being given, 8 being taken, everything balances itself out. So does the numbers make sense? If it's neutral. Okay, and that's why I asked the very first question, is it neutral or is it charged? And we'll do a charge in a minute. Yes, sir. Hold that thought. We're going to get to that. Okay? All right. Let's do one more together. So, NaClO. Little mini quiz. Do not say this out loud. Do not say this out loud. Do not say this out loud. In your brain, what is the name of that thing? I asked that because it has a polyatomic in it. Shh, 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 shh. Brandon, what is it? What is it, Brandon? You don't know? It's sodium what? Chlor. Ide. ITE. Hypochlorite. Okay? Sodium hypochlorite. All right, so let's just start our rules. First question. Follow them. Determine if the compound is neutral or charged. Do you see a positive or negative with your eyeballs? Nope. So what is it equal to? 0. You're starting to see the flow. Next question. Anything by itself is 0. There's nothing by itself. Move on. Number 3. Do you see a metal? Who is it? What's its charge? +1. Very good. So I've got a +1 up top. That's my oxidation number. Move on to step 4. Fluorine always. Don't need it. Number 5. Oxygen usually. Yes. What's its charge or oxidation? -2. Number 6. Hydrogen. Don't need it. Well, who's left out? Got to solve for chlorine. All right. So let's do our math. +1 times 1 is 1. -2 times 1 is -2. Basic common sense numbers. I've got 1 positive. I've got 2 negatives. I need to make it equal 0. So what do you got? A +1. Do I have to divide by anything? No. So what's my answer? +1. I want to give you 2 more. I know we're running slim on time, but I really want you to try these by yourself. See what you can come up with. These are the last 2. Yes, please do these last 2 by yourself. SO3 and I'm going to have to make one up. Let me give you a hint. I know this is going to sound weird. Solve for chromium in the second one. Don't act like it's a metal. Solve for it. Just like we've solved for the ones in the middle. Solve for chromium. All right, so again, first question. Michaela, you've already read it. What's my first question? Is it charged or neutral? So answer that one for the first one for me. So it is neutral. What do I set it equal to? 0. Okay. All right, so my next rule, anything by itself? Nope. There's more than one thing. Metal present? Yes or no? Nope. Move on. Step 4, fluorine. Nope. Don't have that. Step 5, oxygen. Yes. So it's negative 2. Bring it down. Negative 6. Basic simple math tells me I need a positive 6. Well, I don't have anything to divide it by, so sulfur is positive 6. Cool with that? All right, let's look at the next one. Michaela, again, neutral or charged? Not nope. Neutral, set it equal to 0. All right. Second question. Is anything by itself? No. Third question. Do you see a metal? And again, I gave you the hint. Ignore chromium. It's a part of the polyatomic. So we know potassium. What group is it in? 1, so it's plus 1. Do I have anything to multiply by? Yes, that's plus 2. We know oxygen, and I'll kind of skip several rules because of time. I know that's negative 2. Bring that down, that's negative 8. And again, I know basic math tells me that I need a what there? Positive 6. Do I need to divide by anything right here? Nope, so that's going to be my answer, positive 6. Everybody get both right? Good. Is it easier than you thought it was going to be? Tomorrow we will add the charge, so the math is the only thing that changes. You've actually got to not neutralize it. Yes, sir.